All right, we're going to start off this with a question, and that question is: you start with $1, which doubles every day. How many days will it take for $1 to be worth $128? And we're going to try to use this in order to kind of address our new topic here today. So let's take a look at this. So the only way that we know how to attack this right now is we can plug numbers into a calculator. Or we can just kind of list stuff out. So let's list stuff out. So because we start with $1, that means in the beginning, or on day 0, we have $1. After 1 day, we have $2. After 2 days, we have $4, and so on. And so we can kind of continue this pattern. 3 days, it's 8. 4 days, 16. 5 days, 32. 6 days, 64. And 7 days, 128. So our answer to this question is 7 days. It takes 7 days for my $1 to turn into $128. So we're going to use this. We're going to come back to this, circle back after we check out a couple little math properties and see if we can come up with maybe a little more concise way to do this as opposed to just plugging numbers in and listing all these options out. Hopefully a quicker way to do this. So the first thing I want to do is we want to evaluate each log. Hopefully we've worked with logs long enough that we can kind of go through this process relatively quickly. So we'll check out the first one here. First one is log base 2 of 8 squared. And the 8 is the thing that's squared, so we can simplify that to log base 2 of 64. And the question is, 2 to what power equals 64? So, in order to simplify this or evaluate this log, we've got to figure out what power of 2 gives us 64. If you want to pause the video and do this on your own, you can do that now. But I'll give you the answer here. Happens to be 2 to the 6th power equals 64. So when I evaluate log base 2 of 8 squared, the answer is 6. 2 to the 6th power gives me 8 squared, or 64. So same process here. We're going to simplify, and we're going to say this simplifies into log base 4 of 4 cubed. So 4 times 4 is 16, times 4 is 64. So now we want to know 4 to what power equals 64. That's the question. Again, pause the video if you want to try it on your own. But 4 times 4 is 16, times 4 gives me another 64. And so our answer here is 3. 3 is the exponent on 4 that gives me 64. Last one over here, log base 5 of 25 to the 1/2. And we talked about square roots being the same thing as fractional exponents. So we can rewrite this as log base 5 of the square root of 25, which we know is just log base 5 of 5. And our answer is 1. 5 to the 1st power gives us 5. So for this next part, we want to attack these a little bit differently. And we already know what the answers are, so hopefully we can check back up and see if our answer makes sense. So what happens is, what I want to do, rather, is I want to attack these as if the exponent wasn't there. Okay? So we're just going to blank out this exponent, and we're going to simplify this part first. And when we do that, we know that log base 2 of 8 is going to be 3. So log base 2 of 8 equals 3, because 2 to the 3rd equals 8. So our answer is 3. Now, how does that relate to what we had up here? Well, 6, our answer for our original problem with the exponent on it, is the answer to log base 2 of 8 squared. Log base 2 of 8 is 3. So how do these two relate? Well, if I just take this answer and multiply it by whatever we saw up in the exponent, it actually gives me this answer up here. Okay, so let's do a couple more, and then we'll kind of tie this all together, hopefully, and give you an idea of what's the point here, what we're talking about. Okay, so same approach on the second one. I'm going to approach it as if that exponent wasn't there, and I'm going to simplify this guy right here. When I do that, that's a nice easy problem. Log base 4 of 4. I know that 4 to the first gives me this number right here, so my answer is 1. Well, how do I go from here to here? I multiply it by 3. And what happens to be our exponent here? 3. So if I just multiply my answer down here by whatever the exponent was, it gets me back to the answer to the actual question. All right, one last time. Let's look at this last one. It's kind of a nasty exponent on our argument in there inside the log. So again, we're going to attack it as if the exponent isn't there, and just say, well, log base 5 of 25 is just 2, because 5 to the second gives me this number in here. And so we go back up and say, well, how does this relate to the answer to the actual question? Well, if I multiply my answer here by the original exponent, 2 times 1/2, it actually gives me the answer to the original problem. And so hopefully you can kind of see what's going on here. Essentially, we can attack these as if we're solving the log without the exponent on it. And then at the end, just multiply it by whatever that exponent is. So this turns into our original problem of log base 2 of 8 squared actually turns into 2 times log base 2 of 8 without the exponent. This problem here, log base 4 of 4 to the third, actually turns into 3 times log base 4 of 4. And this last one here, log base 5 of 25 to the 1/2. Actually turns into 1/2 the exponent times log base 5 of 25. And it makes these problems a lot easier because we know what log base 2 of 8 is offhand. We know what log base 4 of 4 is offhand. And we know what log base 5 of 25 is offhand. And we can just multiply by the exponent. So to formalize this a little bit, it's called the logarithm power rule. What I usually refer to it as is actually the lasso rule, because if we just lasso this exponent and pull it out front, we get this equivalent expression, and we can solve these things a lot easier. So logarithm power rule, or the lasso rule, I like to call it, because we just kind of lasso that exponent, pull it out front, and it gives us an equivalent expression. All right, so let's go back to our original problem. You start with $1, which doubles every day. How many days will it take for your $1 to be worth $128? Well, what we're doing is really just, in order to figure out after day 1, we're multiplying it by 2. After day 2, we're multiplying it by another 2, and then another 2, and then another 2, in order to figure out how much we're going to have after a particular amount of days. And so hopefully you can see that this is really just figuring out how many 2's do we have to multiply our original amount by to end up with $128. So we can rewrite this as, here's the original amount, and I'm multiplying it by 2 a certain amount of times. And we don't know how many times we have to multiply that thing by 2 by to get the 128, so we use our variable. And we want to know, when is this equal to 128 bucks? So this is our question, and we can simplify this. We usually don't write the 1 out front into a question like this that looks like 2 to the x equals 128. So we've got this nice, neat equation here, exponential function here, exponential equation, and we want to look at like, how do we solve this? Like, what's the process in order to get this x by itself? So instead of having to list out all these different results, we can just jump right to the answer. And the answer really has to do with that age-old algebra rule where whatever I do to one side, I have to do to the other. And we can use that to our advantage here. So what I want to show you is if we take the log of both sides, so log of 2 to the x equals, and I took a log of one side, so I've got to take the log of another. And just to review, if we take the log with no base, it's an inherent 10. So it's a base 10. And whatever I do to one side, I've got to do to the other. So log base 10 of 2 to the x equals log base 10 of 128. So what happens is we go back to this rule and we say, all right, well, I've got an exponent up there. And I know that we just looked at some examples that say, well, if we just pull that exponent out front, right to the front, I can get it down out of that exponent. I can actually get it by itself, and that's exactly what we want to do. We want to solve for x in this particular case, which happens to be the amount of days for our example. So if I'm rewriting this, there's my x that I'm trying to get together, or get by itself. Everything else stays the same. Sorry, my x should be gone because we pulled it out front. And now I can look at this and say, well, this is the thing I want by itself. So let's get rid of the other stuff. This is x times log base 10 of 2. So I'm going to divide by log base 10 of 2 on both sides. Whatever I do to one side, got to make sure I do on the other side. And the nice thing about this is just some number that we can plug into our calculator. And so is your denominator. And so we can actually simplify this. Over here, these cancel. Over here, these stay, but we can plug into our calculator. Remember, if it's base 10, we don't have to write that base. It's implied that it's a base 10. So log of 128 over log of 2. And if we plug that into our calculator, we should get the same exact answer that we came up with on the original problem. And that was 7 days. So x equals 7, and there's our answer. All right, so let's look at a couple quick examples of how we can solve these things. Here we've got 3 to what power equals 12. We want to figure out what exponent on 3 gives us 12. We know it's not an exact number because 3 to the first is 3, 3 squared is 9, 3 to the third is 27. So it's going to be somewhere in between 2 and 3. So the way that we deal with this is we take the log of both sides. Log of 3 to the x equals log of 12. Pick the log of both sides. And when we do that, that allows us to pull our exponent out front. And we can rewrite this as x times log of 3 equals log of 12. Next step is to divide by this guy to get x by itself. So we divide by log of 3. Divide by log of 3. Remember, these are just numbers. This is saying what power of 10 gives me 12. This is saying what power of 10 gives me 3, and we can use our calculators to find those answers. So this simplifies to x equals log of 12 over log of 3. Use your calculator to find these values. This is about 1.079. That's log of 12. Log of 3 is about 0.477. take it one step further, and we get x equals about 2.26, which is right around what we thought. So in other words, we just figured out that 3 to the 2.26 is about 12. So one more example. I'm going to go a little bit quicker on this one. You'll see this process isn't as painful as it kind of looks. First thing that we're going to do is take a log of both sides. So log base 10 of 5 to the x equals log base 10 of 1,000. X comes out front. So we got x log of 5 equals log of 1,000. X equals log of 1,000 over log of 5. Plug it into your calculator, and you get x equals about 4.292. And there's my answer. So in other words, we just figured out that 5 to the 4.292 gives us about 1,000.